Hi, my name is Ryan Verrett and I'm a product manager at National Instruments. And today I want to show you a brief demo of NI FlexRIO and peer-to-peer streaming. Now, NI FlexRIO consists of user-programmable FPGA modules as well as I/O adapter modules. In addition, PXI Express NI FlexRIO modules have the unique capability of being able to send data directly point-to-point over the PXI Express or PCI Express backplane to and from other instruments without sending any data back to the host controller. So in our demo here today, we're actually showing off both the I/O of FlexRIO as well as peer-to-peer streaming between multiple instruments. In addition, we're actually doing some processing on the FPGA as well. So in this case, we're actually using this set of equipment right here. We have an NI FlexRIO FPGA module, a NI 5781 baseband transceiver adapter module, which has 2 channels of analog input at 100 megasamples per second 14-bit, and 2 channels of analog output at 100 megasamples per second 16-bit. Then we have a PXI Express 5122 digitizer and a PXI Express 5451 arbitrary waveform generator. In the current configuration right now, we're actually synthesizing a waveform, in this case just a sinusoid, on the FPGA. We're sending it over the PXI Express backplane to our 5451 arbitrary waveform generator. That's cabled back to our PXI Express 5122 digitizer, which is then sending that data again over peer-to-peer to the FPGA. And right now, we're simply displaying the data that's going from the digitizer to the FPGA. We're sending that back to the host for display. Now, to show that we're actually doing something useful on the FPGA, I can actually enable a 128 tap FIR filter. And right here, you see that the filter isn't actually doing much. That's because it's a bandpass filter centered around 10 megahertz. Now, if I change the frequency of the signal that we're synthesizing on the FPGA, and again sending to our arbitrary waveform generator for generation, you can see if I go below 10 megahertz, our time domain signal is greatly attenuated, and then you don't even see the signal in the frequency domain anymore. Again, I can go back to 10 megahertz, and then also go above 10 megahertz, and you see the signal again attenuated. So that's the filter. If I disable the filter, the signal comes back, and again we can change the frequency, and you don't see that impact of the filter. Now, in addition to using our peer-to-peer streaming with our instruments here, we can also use the input on the front, or the inputs and outputs on the front of the FlexRIO in the 5781 baseband transceiver adapter module. So, for instance, I can choose to, instead of generating on the 5450, generate out of the 5781 and select the appropriate input on our digitizer. There are 2 channels on the digitizer. So now I'm generating out of the 5781 adapter module and acquiring on our digitizer here. Same thing applies. I can use the same filter, do the same thing to our waveform. Again, if I go to 10 megahertz. Now again, in this case, we're no longer sending data peer-to-peer from the FPGA to the arbitrary waveform generator, but the data we're synthesizing on the FPGA is actually being generated out of our 5781 adapter module. I can also choose to acquire from the adapter module, and now we're actually generating on the adapter module, looping back, and then performing the filtering and display. So enabling and disabling the filter, you can see we get the same behavior. So again, we're showing off the I/O capabilities on the front of the FlexRIO, peer-to-peer streaming over the back over PCI Express or PXI Express, data streaming, and we can do this at rates up to 800 megabytes per second, as well as the processing power of a user-defined FPGA, in this case a 128 tap 10 megahertz bandpass filter. Thank you very much.